Hey, what's up, Camp Nerd fans? We are back with a tutorial, and today we're going to be starting the NDS. It is the Nerd Diagnostic Suite, and we're going to be doing this in steps. And what we're going to be doing is I'm going to show you how to get all the information, such as the manufacturer, the model, the OS, the BIOS, what version you have, everything, your processor, your OS version, the system SKU, the battery status, and stuff like that. Over the next couple of tutorials, we'll be going over how to implement WMI as well as your circular progress bars. Now, I'm not going to go into detail on how to build the circular progress bar. If you do not know how to build the circular progress bar, then watch my tutorial on how to build a circular progress bar. There will also be a link in the description as well, so you can watch that video too, and also how to implement perfmon. Now, let me explain a few things between the percentages that you see here, and then also the percentages that you see in the task manager. It's going to be a little bit off on what you see, as far as you see the CPU is 28%, and then here it's 10%, 21. It's about 5 to 8% off. Now, with that, what the reason why is Task Manager uses NT query versus we are using WMI. It's pretty much the same thing. It's just that you're pulling the value from WMI. Or perfmon, actually. You're pulling the value from perfmon, and perfmon pulls from a combination of different things, also including the NT query. So the NT query is a much in depth, and it's pointed more towards, I would say, difficulty of about a medium to hard. You have to be able to program type def structs and things like that, which is, we'll get more into that, and you can actually build an application that replicates the task manager. Perfmon is just a light version of task manager, I guess you could say, and you can do some tweaking to actually get it to where it's close. But if you wanted to get a list of like the processors and things like that of what's going on in the background, you will have to do the type def structs and through the NT query. But for now, we're just going to focus on the WMI, the Windows Management Instrumentation, which is WMI, and getting basic information, then eventually plugging the NT query in to give your application more of an oomph in power, and be able to have that oomph and be able to do everything as far as like perfmon, task manager, and things like that. I'm gonna call it as a hybrid application. It's not focused on just one scenario. It's focused on several different ways to do it, and with that we will be doing MVVM. But for this, just so you can get the idea and how to do the WMI, we're just going to do a non-MVVM, which is, it would be better to do it MVVM if you're going to have a lot of stuff on there. So keep that in mind. You can build classes and call the classes and things like that. But I'm just going to give you the basic on how to pull the data from the instances within the WMI classes. So what we're going to do is we're going to focus on this lower part right here, and that is what we are going to be getting. Now also, If you would like to see how to do the RAM, the disk, the CPU, and the network, stuff like that, there's some simple things behind that, and there's also some complex, such as math and stuff like that. Perfmon is pretty much straightforward. They do all the work for you in Perfmon, so you can get that up and running. So, without further ado, let's get into the actual program. Now, what I have done is I've already built a basic outlay. I already have the uh, circular progress bar built into this as well. As you can see right here, it's the radial progress bar. If you would like to implement that in, then be sure to watch that video, and that'll get you up to speed to where we're at right now. Okay, so within your grid of your main form, you want to have a few different things. And the first thing that we're going to look at is just the text. Do you use a text block or a label? All right, I say you use a text block. So what we are going to do is you can either do this as a drag and drop, or you can actually program it over here. We're not going to be doing like grid columns or anything like that. This is just a basic thing. You can go in and you can do the grid columns and things like that. You should be up to speed. If you're watching tutorials on WPF, then you should know about how to separate your grids and grid columns and things like that. This is just a simple tutorial on how to show you how to get those values pulled. So what we're going to do is we're just going to pull one text block over just for the moment. All right, and we're just going to kind of get it laid out as far as like the text color, and we're just going to put the text color as white so you can see that. Then we're also going to leave everything pretty much default and just bring up the text block itself so you can see it. And what we're going to do is we're going to place this right there, and then we want to come over here and on wrap, on the text wrapping, we want to put no wrap like that. So when we come back over here and we're going to copy it and we are going to paste it and just pull this down like that. So we have some text blocks to work with. Okay, and I'm going to be going over just a few different things at first. You can add some buttons and some different pages and things like that. And we're going to go over, let's see, how many text blocks is that? 1, 2, 3, 4, 5, 6, 7. What we're going to do, we're going to do 10 text blocks. And that should just give you an idea of what it is. So that's 3, 6, 9, and 10. All right. Now, what we're going to do is we're just going to bring this over here. You can put your, however you want to lay it out, stuff like that. Like I said, this is just a simple tutorial. Okay, now, the first thing what we need to do is we need to see what classes are we going to call. All right, so if you go to the docs.microsoft.com, I will have this link in the description as well. This will go to your processing classes, such as your processor or your battery, your system info, and things like that. Now, what we want to do first is we want to add some things to the application. All right, so if you come over here and click view and go to code. All right, so the first thing we have right here is our code. All right, now you need to reference the WMI, the Windows Management. So how you do that is you come over here, you click on the references, and you add a reference. All right, it's going to be under assemblies, and you're going to come down and you're going to look for the system.management, and you're going to click that. And then you're going to press OK, And then if you look at your references, it added the system.management there. So what we need to do is we need to type in using system.management like so. All right. Now, what we need to do now is we need to add a timer, and this timer is going to be for the circular progress bar. All right, and we are going to use that timer just for one circular progress bar to kind of give you an idea of what is going on with the perfmon and everything. So we're going to go ahead and add that first off just to get the this kind of set up, because we're going to be adding it later on. All right, so the first thing you need to do to add a timer is you need to put in system.windows.threading.dispatcher timer. So you're going to come down and you're going to find dispatcher timer, and then you're going to name this. I'm just going to put it as timer equals new system.windows.dispatcher timer, and then we're going to close it off like so. Okay, so what this does is this gives you the whole dispatcher, the timer, pretty much what you would see in the WinForms timer. You would just drag and drop it and set it. This is actually building it in code from how you would see in the WinForms. Okay, so now under the initialize component, we need to add the timer.tick, and this is going to create the timer.tick event. So it's going to be new event handler, and we're going to name this event handler ourselves, and it's going to be tick underscore, and then it's going to be well, we can put timer and then put it underscore and then take that off like that right there. Okay, so to generate the method, you're just going to click on that and it's going to generate the method right there. Okay, now under your timer tick event handler you just created, you want to put timer.interval, and then this is going to be equals new time span. And now I want to elaborate on this time span because you have different options that you can do. Now, if we add a 0, you're going to see in your box, you're going to have int hours, int minutes, int seconds. All right, if we add another 0, which would be the minutes, then you're going to see the seconds. And then if you go and you add one more 0, then you are going to see that it has several overloads, and that goes into like your milliseconds, microseconds, and things like that. And it's something that you could look at as far as right here. It's got the 4 overloads, and so what we're going to do is we're just going to leave this as seconds, so you just need that right there. All right, and we'll go more in depth on another tutorial on building a timer, being able to execute like days, years, months, weeks, several things like that. So the last thing you need to do with this timer is you need to have the timer.start. Okay, now we have the timer built in. All right, so with this timer, you can do several different things. You can add a clock, things like that. And to show you an idea what you can do with the clock, all right now your timer is set at 0000. So we're going to do this as a clock. So we're just going to type in 1. Now, it's going to be pretty much the same thing as 1 second for the circular progress bar as well. So you can do that, or you can create multiple timers. I would suggest, if you're having multiple timers, to do that in classes. So what we need to do is we need to come back over here, and with this text block right here, we need to name this, and we're going to give it a name as clock. All right, so now we can come back over here and we can put, well, let's come back over here and let's put an LBL. I always like doing LBL. Even though it's a text block, it's still going to be considered as a label. So we can do LBL clock dot text equals. And now this is where the clock comes in handy. All right, and you can actually do a private void underneath that, and you're going to put private void, and then it's going to get time. And then under this, you're going to call the date time, and it is going to be called date, and then it's going to be date dot, or no, it's going to be date equals date time dot now, and then you're going to close that off, and you're going to come under there and do the LBL clock dot text equals date dot, and then you can do too long time string or too long date string. Date string. So we're going to do the too long time string, and then we're going to concatenate that, and we're just going to space it out a little bit, and then we're going to put date dot too long date string, and we're going to close that off like that. And then we're just going to come through here and we're just going to add some stuff there. Now within this timer, you do not have to call the label because you have everything right here, and so you can just call the get time like so. All right, now to show you, and what we're going to do is we're just going to bring this text block and we're just going to set it, I'd say about right there. All right, so now when we come up and we start the application off firsthand, you'll see that it gives us the time, Wednesday, January 23rd, 2019. Now, if you don't want the seconds on there, then you would do the short date. And so to give you an idea what the short date is, you can go and you can do dot to short time, and then to short date string, and then when you start that, you'll see that it gives you this option right here. All right, but I like it to have a little bit more of detail. So we're going to leave the long date and we're going to keep the short date. Have it a little bit of mix. Have the best of both worlds. So you see 8:31 a.m. Wednesday, January 23rd, 2019. Now you can move that text block around and put it where to where it's a little bit centered. You can also, like I said, do your grids and your columns and things like that. Okay, so now let's go back over here to the classes, and I'm just going to leave the link to this one. You can actually come over here in the side part and you can choose which one you want. So the very first thing that we're going to do is we're going to go to the system info. So look through here and you're going to find the system info, and it will be under the operating system. And you're going to come down to, where is it at? Where is it at? Where is it at? The system driver, system desktop. It's going to be computer system product. So let's go back up to, all right, computer system. All right, you've got the computer system here. Now, with this computer system, it's going to give you a few different things in here. All right, now this is not the one we want. So let's go back up to your hardware. Computer system processor. Right here, and you'll see a few things, and then you can also come down. There's several different things. I'm trying to remember which one it is that gives you the memory and everything. It's the Win32 computer system product, which is, if I am correct, it is going to be should be under the system classes, the operating system classes. It gets kind of, what you want to call it? It's kind of hard. You got to remember where all these are at. And even looking through here, you can see all the classes that are in here. So you can actually build a pretty decent size system on this. All right, so let's see, where is it at? All right. I have not had my coffee this morning, and I am at a total loss. Okay, let's go to, all right, computer hardware classes. All right, going through baseboard, battery. All right, you know what? We're just going to do the battery offhand first. All right, so we'll get to that one here in just a second with the system info. So what we're going to do is we're going to get the battery system. All right, so let's go back over here to the code. And we are going to do the first thing is we are going to do a private void get battery. Like so. All right, so over here in this text block, we are going to give this as an X name. And this is going to be called LBL battery charge. Okay. Now, we're going to leave this right here. And so with this private void get battery, we need to add the system dot management class, and it's going to be WMI equals new system dot management class, and we're going to close that off like that. Now within here, always remember this is where your class goes. So I'm just going to label it as that right there for right now so we can get everything else constructed. All right, so let me go through and add that to get rid of that little error. All right, now under the class that you're going to reference, you need to put var providers equals WMI.get instances, and you're going to close that off like that. Okay. Now, what we are going to do now is, since we are doing the Win32 battery class, this is what you're going to use. So you can just copy that and then put right here within your class your Win32 battery. All right, now you almost have everything set up. So what you're going to put now is you're going to put a for each loop for each var, and then this is going to be provider in providers. Now let me elaborate on that. Your for each var provider, you see, this is your providers. This is your keyword that's going to pull the instances from the class, and as you see, it is a provider. So what this is simply saying is, if you see this right here, it's pulling the provider instances. So when you have providers, so your provider in providers, which is pulling from here, this is the information that you are going to be getting. All right, so let's now look at the class, because we have everything from right here completely done. All right, so now we're going to be putting our instances in this for each loop. So what we are going to look at is your several different things. Your uint16, uint stands for unsigned int, which is an integer, which is 16, an unassigned int 32, your string, your boolean, your date, time, things like that. We're not going to go in depth on every single one of these. We're just going to get a few different things. Now, if you come down and if you look at the availability, it gives you the data type, which is a uint16. Okay, now also you would want to look at these right here. If you was to just do a basic just putting in without any if else statements or anything like that, you're just going to get this number. All right, and what you have to do is you have to compare if whatever you're pulling is equal to 15. So for this example, would be availability. If availability is equal to 15, then you would want the label to say power save standby, so forth and so forth. So what we are going to do is we're going to do the battery status. All right, now with the battery status, what we need to do is we need to come over, and above the for each loop, we need to put in int battery status equals, then it's going to be convert dot, and then if we come back over here and look, we'll see that it is a uint16. So we need to convert that to an int 16, and then it's going to be the provider, and then within what we're going to be pulling with that provider is battery status, like so, and then we are going to close that off. Okay, so with this we need to have the provider, and this is going to be a convert dot to int16, and then provider. I'm just making sure I have everything correct because we have an error here, and let me go. This is a, oh, no wonder the reason why it's not going correct. It has to be in the for each loop. My bad. Okay, so now since we have that in the for each loop, now we can go in and we can do the if statements. Okay, so if you look over here at battery status, you've got other unknown, fully charged, low critical, stuff like that. Okay, so what we are going to do here is we are going to add the if statements to this. So if, and then remember we used battery status, and it's a good idea to keep these the name of what you are using. So if battery status is equal to 0, and then over here, this right here, it's we're going to change that and we're going to put status. Okay, so we can put LBL battery status dot text equals, and then this is going to be battery status, and then we're going to concatenate a space in there, and then we're going to concatenate, and then it's going to be other, like so. All right, now what you can do is you can just take and copy this, come down, and you're going to paste several of these. So now you can come back up here, like this is 0, and then this is going to be 1, and then this is going to be 2, then this is going to be 3, and you're just going to go down the line and you're going to number each one the respected number, like so. Seven. We're just going to add just a few more. So that is going to be 8, 9, 10. And so now what we need to do is we need to come back over here and look and see which one is which. So you've got unknown. So we're going to, so what I'm going to do is I'm just going to move this over to my other screen over here, so I can see which one is which. And you're just going to change the other, and then you're going to change it to whatever the actual point is. So you've got other, and then you have unknown, then you have fully charged, and then you have low, and then you have critical, let me go, and then you got charging, and then you got charging and high, then you got charging and low, charging and critical, then you have undefined, and then you have partially charged. Okay, now let me bring this back over to my other screen. Okay, now if you notice that you have other, 1, unknown, 2, fully charged, 3, and if you look over here, you will see that it actually starts with 0. Your index always starts with 0. So basically 0 equals 1. 0 equals 1. 1 equals 2. 2 equals 3. 3 equals 4, so forth and so forth. So you see that we only have the number 10 here when it actually goes to 11. But if you was to add this as 0, and then you would see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you come over here and you count, and it'll be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Always remember, 0 equals number 1. So always start your indexes at 0. Now, to get this, your get battery, instead of putting this in the timer, you're just going to come up and you're going to put it into the actual instance. So it'll be get battery. So that way when it first application starts, you will notice that it will automatically put that in there, and you see that the battery status is fully charged. That's because I have my charger plugged in and it's 100%. As you see here, it says fully charged down here at the bottom, 100%. So fully charged, fully charged. Okay, now what I'm going to do on this next little part of the battery, because we're already done going on 36 minutes so far. And so what I'm going to do is I'm going to add in one more thing, and then we'll stop with this tutorial and we'll continue on the next day. I'm going to show you how to change the class. All right, so to kind of help with everything organized, to know that this is the battery, you want to put your region, and then you want to come down here under your battery, and you want to put hashtag end, not end if, it's going to be end region, like so. All right, so here you can put / battery void. And then you can just roll that up like that right there, and it makes it a little bit more organized. Then you can just come down and you can do region, and then you can do hashtag end region, and then you can put what this is. So it's going to be, now this is going to be your operating system. So now you can just roll that up, and you see this is the operating system right here. All right, so what we're going to do now is we're going to look at the actual operating system within itself. So now that we have the operating system, and we're going to be calling the exact same thing. So what you see here, just copy this, and then you can just roll that back up. And then here you're going to put private void get OS info, like so, and then you can just go ahead and paste that, and now we have this almost ready. So now what you have to do is you have to change the class. All right, so what we're going to do is we're going to look at the class as in the operating system. So what we need to do is we need to come down here, and we need to go to the operating system. All right, now within the operating system, you want to look at the computer system right here. All right, now we know that it's going to be Win32 computer system, so we can just copy that, and then we can come back over here, and we can take that Win32 battery out, and we can put Win32 computer system. All right, so now we can come and we can do the for each loop, for each, and it's going to be var provider in providers. Now we can come through and we can start with what we want to put here. All right, now let's say you want to know what the like system SKU number is. All right, so if we come down and we look at the system SKU right here, it is a string. All right, strings are pretty much simple. So it's going to be string system SKU equals provider, and then this is going to be system SKU number, and then this is going to be dot toString, like so. Okay, so now we need to come over here and we're going to take this text block and we're going to give it a name of LBL system SKU, like so. And now we can come over here and we can just put LBL system SKU dot text equals, and then we are going to call the system SKU, which we're going to concatenate it. So system SKU and then we're just going to call the system SKU dot toString, like so. Okay. Now, whenever we have this, we need to remember to call the get OS info. So it's going to be get OS info, like that. So when the application runs, it'll automatically get that info. And you see that right here is the SKU number. All right. Now, let's say you have something a little bit different and you want to go through string. Let's say you want to you have an int 32 or an int 36. So what we're going to do here is we're just going to highlight and copy this whole point right here. We're going to roll this up and we're going to come down and we're going to put our region and then end region. And then we're going to call this, it's going to be processor info. So we're going to do a private void get processor info. Close that off and we're going to come down like this. All right, so to do the exact same thing, we're just going to call the exact same thing and we're just going to get rid of that right there. So we have everything what we need right here. All right, so we can just get rid of that and now we have our same setup as what we had before. All right, now we're going to go to the processor, which is under your system hardware, and then you're going to come down to your processor, your PNP printer processor. So your Win32 processor. All right, we are going to look at uint16 and uint32. Now, to make this really simple, you see this what you have right here. We're just going to copy that under your battery void where you have your int 16. We're just going to paste, and then this is going to be a 16, and this is going to be 32, and then you already done seen the 16, the 32, and the string. So we're going to put string, and then we'll just get to the string here in just a second. We're going to work on getting the class set up. So you're going to put in processor, and then with your providers and provider, you're not going to have to change those because it's always going to be provider and then provider. So that's pretty much going to stay the same. All right, now what we're going to do is we're going to look into the processor, and we're going to get let's say the current clock speed. So we can come down and come over here to where it says int32. We are just going to paste that, and this is going to be the proc speed. And then we got to have a 16 in there as well. We'll do family. Come over, paste that, and this is going to be proc family. Okay, then we're going to have a string. We will do status. So you can come back over here, and same thing with this, your string, you can just look at that, and it's going to be the exact same thing. So it's going to be string, and then this is going to be proc status, and then it is going to equal provider, and then it's going to be status dot toString, like so. So we have our int16, our int32, our string. Now what we want to look at now is the Boolean. Okay, so I'm just looking at something in my notes over here. Give me just a second, because this is pretty much repetitive. You can do the same thing over and over and over and over again. So give me just a second to bring up is it under text stuff? Nope. Let's bring this over here so I can expand this out. That's my YouTube stuff. All right. Let me bring this over here. All right, now you have, I'm going to leave these on there as well in the description of the int16, int32, the string, and then you have the Boolean. So what I'm going to do is I'm just going to copy this right here, because I also do private tutorials as well, and I'm just going to do this right here. All right, so now that you see power management supported, all right, if we come over here, we'll see right here, power management supported. That is a Boolean. And then that should be it, other than the date time, and we will get into the date time later on. You'll have to parse it to get it to where it's at. So these right here are the 4 basic structures. All right, so now we have family, current clock speed, status, and power management supported. So if we come over here, we're going to give this an X name of LBL proc family. All right, and we're going to give this an X name. And this is going to be LBL proc status. And then we also have the current clock speed. So it'll be X name LBL proc clock speed. And then this is going to be an X name. And this is going to be proc power management. LBL proc power. We'll just put power man for power management. You can name these whatever you want. I just named them the same thing as the instance that we are pulling. All right, now these other three that we have, we can just get rid of those because we don't need those other three. All right, so now what we can do is we have your int16, your int32, your proc status, which is a string, and then your boolean. So with the boolean, what we are going to do first, we're going to start with the boolean and then work our way back up. So it's going to be LBL and then proc power management dot text equals, and then it is going to be a calling the power management supported dot toString. Okay, now the same concept as you're converting a boolean. It's a boolean and you're converting it to the boolean to where it'll actually pull. So if you come over here, as I was saying with the uint16s, they're unassigned integers. uint32 is unassigned integer 32-bit, and so forth and so forth. And you can come through and you can look at all of these as a whole, and you can get an idea for each one. All right, so we have the string, and that's LBL, and the string is the what was the string? Proc status. Okay, so LBL proc status dot text equals, and then this is going to be proc status dot toString, and then this is going to be LBL proc clock speed dot text equals, and then this is going to be proc speed dot toString, and then your proc family, so LBL proc family dot text equals, and then this is going to be proc family dot toString. Okay, so now we can come up and we can call the get processor info, and like so. And so whenever the main window loads, it'll come up. Let's make sure we don't have any errors or anything like that. And you see how it says false, 2703, okay, and 198. I want to show you the reason why it done that. Now, if we go back over here and we look, we pulled the, let's look at the proc family. Okay, when you come down here, it was the, let's see, it was the family. You see family, it's the same thing. It has other unknown 8086, 8286, all the way down through here. All this stuff that you see right here. The reason why I've done it that way is so you can see that if you was to look at your battery void, if you was just to have the battery status, it would come up as those numbers. But here we had to use if statements, battery status. If battery status is equal to 0, then you want the label to say this. Okay, that is exactly what you're going to have to do with these here. All right, for the family, you're going to have to go and put in if family is equal to 1 or 0, you're going to have to put other, and so forth and so forth. Exactly what you did with the battery status. Okay, now if we was to look at the the current clock speed. So if we come up to the current clock speed, it's a UNT32 read it only, it gives it in megahertz. All right, so we can come back over here, and with the clock speed, we can put, we're going to concatenate like we did before, and we can put current clock speed, and then we can come out over here and we can put MHZ like so. Now whenever we run that, you'll see that it will say current clock speed 2703 megahertz. And of course, let's make that a lowercase l, and then bring that like so. Then we start it, and you see current clock speed 2703 megahertz. All right, now let's look at the we looked at the family, we looked at the current clock speed. Let's look at the status. So we come down here to the status. It's going to be the same thing. As you see, it says, okay, error, degraded, unknown. It will automatically give you what it is. This right here was the smart way of doing things. So you do not have to do if statements on this, because it's going to tell you what it is either way. If there's numbers, you have to do if statements. If it gives like pred fail and then pred fail, then you don't have to do it. As you see, it says okay and okay. So you can come back over here and make this a little bit more, what you want to call it, friendly. With the status, you can put, we're going to do the same thing, and you can put processor status is, and then you start it. Then you will see that it will give you a more clear processor status is okay. Your current clock speed is 2703 megahertz. All right, then you got your system skew, and then your battery status is fully charged. You have your date and everything. Now, what we're going to do is we're going to look at the power management supported. All right, so let's go back up here to the power management supported. All right, you see here, it says it's a data type Boolean, which is true or false. All right, the power of the device can be managed, which means it can be put into suspend mode and so on. The property does not indicate the power management features are enabled, but it does indicate that the logical device power can be managed. All right, this property is inherited from CIM logical device. So it's going to be a true or false. All right, so if you're looking at it, you're like, well, I don't remember what that is. All right, so what we can do is we can take that and we're going to highlight it and copy it, and we're going to put that right there so you can see what we're going to be using here. All right, now let me go back. So we can go if power management supported is equal to true, then we can come down and we can put LBL power proc management dot text equals power. You can put power management is enabled, or you can put whatever you want. I'm just doing this to kind of show you an example. And with this right here, you can come down and do else if power management supported is equal to false, then you can put LBL proc power manage dot text equals you can do copy and then you can do paste and you can put is not managed. Something like that right there. All right, now let me go over here on this is expected aware. All right, I've got something somewhere. There we go, like so. You can correct that error. All right, so now once we come up and you see power management is not managed because it come up as false. Okay, so that kind of gives you an idea of what you can do and how to implement your different classes. Now, remember, if you're wanting to change the class, you're going to keep this same structure right here that you have, everything that's within the for each, those three things. Your system.management class, WMI equals new system.management class, and then the only thing you're going to do is you're going to change your class that you're pulling the value from. You're going to keep the var providers and you're going to keep the for each loop there. So the only thing that you have to change going between class to class is your class, the instance that you're pulling, and then everything that is in the for each loop. And then you would have to change what instance you are pulling. So you always call the class and you call the instance of that class. So that is pretty much kind of in-depth way of how to do it. As you see, like the toInt16, the toInt32, the string, and the boolean, all this right here is going to stay the same between every single class. Now, sometimes you may have like an int64 or something like that. you'll see, if you go through, you'll see like the date time, but a lot of it's going to be Boolean. Like if you go to the serial port and get you information on the serial port, you're going to see that it's a lot of Booleans. There is very few strings there. And let's say if you go to the sound, you're going to see that it's going to be uint 16, a lot of strings, Boolean, and there's only one date time. All right, if you go to the video controller, you're going to see a majority of all three of them. All right, let's just go up and let's say plug and play. All right, here you have your plug and play device, which is, this is a sint64, this is a signed integer 64. So you have sint uint. All right, now let's just go up. Let's say memory device. All right, you see you have a uint8. That is a uint8 and a uint64. It is going to be the same concept, except this is a uint8, and it's going to be an additional air data array. And we'll get more in depth on that in the next tutorial, and we'll work on the memory device. We'll actually go through and we might build something on this, show you how to use the uint64, the uint8, things like that. This tutorial has been going on for right about an hour so far. Actually, a little bit over an hour and 5 minutes. So I'm going to end with this. And if you have any questions, leave them in the comment section below. This is pretty much straightforward. You're just changing the class name and what's in the for each loop. Everything else stays the same. And you're also going to change the instance that it is. So you can highlight and copy the int16, int32, string, Boolean, and you can use those in each every one. Just change the instance that you're calling within the class, and you should be able to get everything done from there. And in the next one, we'll show you how to build a more user-friendly UI. Let's say if you want the main window just to be like, say you have a couple of icons and you want to click on, okay, you got a processor icon, you click on the processor icon and it takes you to a whole different page and it gives you all the processor information. Then let's say you got an icon with, say, a memory stick, tells you everything about memory, then fan. I mean, there's several different ways that you can do this and get it up to speed of how you want it. I would say if you're going to do large scale applications like this, go MVVM. And this is just to give you an idea. So everything from here on, everything will be MVVM. So that way you'll have more performance. Your code will be more organized. It'll be more neat. You'll be able to use the power and performance of MVVM and going in and building an application so you don't have any bottlenecks or latency issues or anything like that. And I hope you enjoyed this tutorial. And if you would like to become part of the Camp Nerd family, be sure to subscribe and turn on the notifications. If you like the video, hit the like button. Sorry that the video was so long. The past couple of days I've just been in a loop and everything, so this is the first tutorial that I've done, I think, in about a week and a half, 2 weeks or so. So this should get you to where you can do everything in these classes because it's all the same. It's just repetition. It may look hard at first, but once you get into it, it's just repetition over and over and over and over. You're going to keep the same concept. You're just going to change the class you're pulling from and the instance within the 1632 string or Boolean. So it's pretty much that simple. It's not anything hard or anything. So just keep in mind that it's easy. It's repetition. It looks pretty hard at first, but once you get to looking at how to change classes and do from everything, you can start building big applications like that right there and just keep them going, doing different things, different applications. Let's say you want one application only on the processor, then you have all your stuff from the processor there or for your hard drive. And you can also pull like part numbers, things like that from the motherboard. If you need to replace your motherboard, you can actually get the the model number, the part number, the SKU model, things like that. And this is also pulling a lot from, if you bring up your run dialog box, Windows R, and put in MS Info 32, you'll have the same thing from there. So this is Ian, and I will see y'all guys in the next tutorial. Until next time, keep it nerdy.